Okay, let's get started. So it's weird when it's a celebration that I figured out the screens. I was pretty happy though. I got that figured out to get in the center after I messed it up. But the things we celebrate these days. Just a reminder, I'm in the Discord lecture channel. I'm watching this each lecture. If you have questions, you can put them in the lecture channel on the Discord server, or just do the old-fashioned raise your hand. But I'll be watching this on my phone. I'm going to put it right here, and I'll be watching that. What's up, Dragos Loop? Kevin here. What's up? So let's get started. And we're going to start in IntelliJ today. I'm going to give a few examples of last Friday's lecture. I didn't have time to go into IntelliJ and show those examples, so I want to do those quick. And then while we're in IntelliJ, I'm going to do things a little reversed for today's content. I'm going to start off in IntelliJ since we'll already be in there. We'll see coding examples of data structures in Scala, and then we'll go to the slides and talk a little bit more in depth about them and also remind you of the syntax. We're just trying to get the syntax down for these data structures. I don't want get showing on there. I don't want that showing either. So first, let's do a quick reminder, quick review of this object that we saw last time, this function, this method that's going to split a string. I don't want to talk about this one. Don't want to talk about this one, but I want to talk about this example right here. So we have this string that's various either true or false, separated by semicolons, and we want a method that takes a string in this format and tells us what percentage of these values are true, and we'll represent that percentage as a decimal. So with this input string, we would expect this to return 0.8. Oh, come on. We would expect this to return 0.8 because 80% of the values are true. We're going to call compute percent. We're going to split the string on semicolons. We're going to initialize a few values that will keep track of the count of how many values we've seen and how many values were true. We're going to iterate over all of those splits, all of the values, convert each one to a Boolean, count if that Boolean is true, increment the number that we've seen that are true, and regardless, always increment the total count. After looking at all the values, divide true count by total count, and if we run this, we should get our answer 0.8, 80% true. Now, since I'm in IntelliJ, I can modify this, and again, I strongly recommend that you do this. As you're going through lab this week, if you've already had lab, you've done this, but you'll clone this repo and have all these examples in IntelliJ ready to run. And once you have that, I recommend changing things around, predicting what that change is going to do, and then verifying if you're right or not. What did that change do? So I'm going to make a quick change here. I'm going to change total count and true count to ints. And I want to run this again. That's the only change I want to make. And I want to know, what's this going to do now? Is this still going to give me the right answer? What's going to happen when I run this code? You can't see anything? Can you see this in the back row? Yes, no? Not really? It looks so big up here. I forgot it only does that. I wish that was just the global font. We don't need this sidebar at all. Better? Good. Please switch to dark mode. Is that going to be easier to see it though? I think the light mode's easier to see in lecture. I mean, we can try it. Anybody have an answer for what that's going to run? I'm just messing around while I wait for a good answer. Is that better, worse? Well, you're in the front row. You can see it no matter what. Damn it, Nicholas. I actually been liking high contrast. I'm going to try high contrast and see if we can get some feedback. Good? Is that a good or a bad mode? Worse? Dark mode or light mode? Okay. That's confirmation for sure. Better, dark mode better, 10 times better. Okay, good. I'll take that as solid confirmation. It's usually hard to get feedback, but that one's pretty clear. Dark mode's better. All right, so what's this going to do now that I changed those to ints instead of doubles? So for those of you who couldn't see before, these were doubles, and I changed these to ints. We're computing how many, specifically on this input string, how many of these are true. We ran it, it was 0.8. 80% of these values are true. We're going to run this again, but with total count and true count being ints instead of doubles. They were doubles before. If I rerun this, are we still going to get 0.8? Yes, no, why, or why not? Yep. Yep. Exactly. So we're going to get a 0 here. Percentage true, 0.0. Of course, the wrong answer. What we ran into is something we talked about last time, integer division. So when we divide true count by total count, before there were doubles and it just did math the way we expect math to work. But now that they're both ints, we're going to get, I'm going to do something fancy here. Bear with me. Well, we'll bear with IntelliJ for now. Internal errors, logs for more details. But why? All right, don't bear with me. We're not going to do that. All right, but we get 0.0. But true count is 4, total count is 5. Once we divide those, since they're both ints, we're going to get integer division, and the result has to be an int. So when you're trying to divide 4 by 5 and you're getting 0.8, if you're trying to stuff 0.8 into an integer, it's not going to happen because you have a decimal portion. So IntelliJ has to make a choice here. The choice that the language makes is by truncating the decimal point. It takes anything after the decimal point and just throws it away and gives you just the 0. So instead of 0.8, you just get the 0 because 0 is an int. Now at that point, Scala says, whoa, crap, you gave me an int, but I'm supposed to return a double. And Scala's going to auto-convert that 0 into a 0.0 double, but that's after the integer division already took place. So the integer division gave us an int, and then that int is converted to a double. Scala won't look ahead and say, oh, we're returning a double, so let me keep your floating point. The truncation, the integer division, that already happened before it was converted to a double. So there are a lot of ways we can handle this. We could do 2 double. That's going to handle it. We could do times 1.0. Now, since we're multiplying, this is a double because I specified that it has a decimal portion. Now we have an int times a double, that's going to return a double. Then a double divided by an int, that's going to return a double as well. It's only when both values are ints that you're going to get integer division, or if they're both longs, or an int and a long. But now we have an int times a double divided by an int. We're going to end up with a double there because one of those values was converted to a double. So a few options there. The one I went with was just having these doubles to begin with and calling it a day, and just never worrying about integer division after that. I don't have any ints. How can I get integer division? Problem solved. But there are many options. Feel free to choose whatever one you want to go with. Just always avoid that integer division if you want the decimal portion. All right, the next example from last time, we saw this example. We have a file name. I'm going to call this convert file to string method and then just print the thing to the screen. This method is going to read that file using source.fromFile, which has to be imported. It's part of the Scala library. It comes with Scala, but it does have to be imported into our project. Yeah?
I have a question, but it's about string splitter.
Mm-hmm.
So if Boolean is Boolean, how it becomes true?
So the value as Boolean, if it's true, we're going to increment the true count. And then the total count is outside of that conditional, so that always executes. Is that your question? It was.
I'm saying, I thought it would count all the Boolean values instead of if it's true.
So if since I'm converting this to a Boolean, this is a Boolean expression, and the value is either true or false depending on what the string was. So if the string was false, what we're going to get right here is if false. So once we have if false, because we converted the string to a Boolean, so once we have if false, we're going to skip right here and not increment true count. So I'm using a little bit of shortcut of taking the fact that it's already a Boolean and just straight up putting that Boolean in my conditional as my conditional. It would be the same thing as saying if. It'd be the same thing as doing this, but since it's already a Boolean, I don't have to check against true. I'm just going to say if the Boolean. Got it? Yep. All right. Good question. Because that's something you probably haven't seen in 1.15. We like to make things more explicit in 1.15. I'm going to start using more shorthands and like tips and tricks like that in 1.16. So we're opening the file. That's going to give us something called a buffered source. You don't have to do it like this. I like separating it at this point because I want to show you what's going on. But that's the same thing as doing this. You can go right from the source all the way to the lines if you want, all in one line. Feel free to do that if you want. I'm going to stick with this just to be a little more explicit. Kind of goes against what I just said about the Booleans, but this is a little more new, so I want to be more explicit about what I'm doing. So I'm going to open the file using from file, and the buffered source class has a method named getLines. I'm going to call getLines is just like read all lines in Python, and that's going to let me iterate over the lines. Unlike Python, you don't have the trailing new line, so if you're used to worrying about that trailing new line, we're not doing that in Scala. That new line is removed from the strings that we're iterating over, for what it's worth. So now we're going to use our for loop. For variable name in data structure. This is going to iterate over the lines of that file. And I'm not doing anything necessarily interesting right now. I'm just concatenating all of the contents of the file into one big string. This is not, I said this Friday, I still saw it on the Discord, this is not something you want to do. There's no reason to really ever do this unless it's very specific to your situation. You don't, this is just a lecture example, just to show you what we can do with files, how we can read files. You don't want to necessarily put them all in one string. Instead, you would do your processing in here. You would say like, if line, this is where you do something, combine the previous example with this one. Val splits equals line dot, you're going to do something like this for your lecture. Something like that for your lecture task. And then do, splits of 0, splits of 1. Access that data, do whatever processing you need to do with that data right inside the for loop. There's no reason to convert it to a string, one big string with this whole file, and then process it later. Just process it while you're reading the file line by line. But just for a lecture example, I don't want to show you all the solutions to everything. Just for a lecture example, I just concatenated it into one big string. The one big thing I want to note that I didn't mention on Friday, the file name that you read is relative to the root of your project when you're running this in IntelliJ. So what does that mean? If we go to the project sidebar, the root of your project is the top level directory of the project. That's where your programs are being ran from. So any file paths have to be relative to that. So I'm looking for a file name in a directory data named testfile.txt. So starting at the root, I'm going to go to data, testfile.txt, and that's where Scala is looking for my data. If you put your test files inside of your test package or inside your SRC directory, your code's not going to find those files. So make sure you have your test files in the right spot to make sure that you can find those files. And if we run this, we should see this exact content being printed down here. So we're reading that file from that directory and being able to use that code in that text in our code. And the projects will follow the same structure. I'll have a data directory at that top level right here, and then that's where cities.csv, right? And countries.txt are going to be in a data directory there. So in all your tests, you have data/cities.csv, etc. And that is, I do say, you do have to use the input file name, but I do actually follow the same convention in Autolab. That's exactly where the files are going to be. All right, any questions on this example? How do I install IntelliJ? I mean, that might not be a joke at this point. How do I install IntelliJ? We just talked about it a lot. I won't do that in lecture again. Did I do that in lecture? Probably not the installation part. But in lab this week, if you haven't had lab, the TAs will hook you up with that. And if that's not enough, come to office hours. We're starting to get the schedule up. I still don't have my office hours up there, but a lot of TAs are having their office hours posted on Piazza. So check out that schedule and go to office hours as well. We have a mix of in-person and online office hours. So make sure you look at that closely and show up to either the Zoom meeting or Davis 302 according to the schedule. Okay. No questions on reading files? And we do, just a reminder, we do cover a lot of content in these first few lectures. On Friday, the pace of lecture will slow down significantly. Right now, there's a lot of review topics that we're just covering in Scala. So I go fast through these, and today won't be an exception. We're going to cover 3 data structures real quick here. And then Friday is our first 116 specific topic. Then the rest of the semester is 116 stuff after that. So the pace will slow down if the pace is a little quick for you. But the assumption, again, is that you understand all these concepts. You're just learning the Scala syntax. If that's not true, you have some 115 review to do. But Friday, the pace will slow down. I'll talk a little slower. The lecture will just give you more time to digest during lecture itself. But today, let's get to some data structures. This is today's content. I'm doing a little backwards. Usually I start with the slides and then jump to IntelliJ. We're staying in IntelliJ and then switch into the slides after. So this time I will run the debugger. I was trying to run on the other example. I don't know what went wrong there, to be honest. But I did test this one right before lecture, so if this one doesn't work, then I'll really be swearing at IntelliJ. But this is something I'm going to use throughout the semester when I'm in IntelliJ to show you what's going on in your programs. And I strongly, strongly recommend that you use this in while you're debugging your programs and you're writing your programs. So this is what's called the debugger. It's built right into IntelliJ. If you want to run the debugger, at least for now, I recommend putting a breakpoint at the first line of your main method. You can do that by clicking right next to the line number. Once that red circle's there, that's a breakpoint. And then when you run your program, instead of going to the green play button, go to the debug button and click that. What that's going to do is run your program until it hits a breakpoint, which we put on the very first line of the program, so it's going to stop right away. Show us a lot of information about the program, and let us step through it one line at a time while absorbing all kinds of information, specifically, most importantly, what values are in all of our variables at any given moment in time. So here we just started out. We don't have anything interesting here. We have args, and we have a reference to the object that's being called. 2 things that we're not interested in at the moment. And then immediately we're going to call my array methods example. And we're going to jump into some new content right here. And we're going to see all the local variables. There were no arguments in this method call, so there's nothing to show. We just have a reference to the calling object, which is something that shouldn't make sense to you yet, unless you've studied object OOP before. I'll assume that this doesn't make sense to most of you, and we're not worried about it right now. For all intents and purposes, we have access to no values or variables right now. Now, the first thing we're going to do is create an array, which is just like, no, I can't say that. I'm just going to, just like an array in JavaScript. Slightly different. I can't really say that either. Let me just say it's an array. It's a Scala array, and I'll save more explanation for the slides. So I'm going to create an array with values 2, 3, 4. And this is a data structure, our first data structure in Scala, which the big important thing to highlight here is that we need a type for the data structure. So every value and variable, every parameter, everything, a return value, everything needs a type in Scala. So the type here is an array, but data structures also need a second type, which we call a type parameter, which is the type of values that can be stored in that data structure. So this isn't just an array, and later it won't just be a list, it won't just be a map. It's going to be an array of ints. And this array, for its entire life, can only store ints. That's it. Can't store doubles, can't store strings, can't store other arrays. Ints only are allowed in this data structure. So we create an array of ints, and if we try to give it something that's not an int, this might break things because I'm running the debugger, but I'll just rerun it. Well, that would definitely give me an error. I think because I'm running the debugger, it's not showing me the errors. But I can't put other types in there. They have to be ints. If they're not ints, I'm wrong, and the compiler is going to say, you can't run this program because you have to fix your typing. Your typing's not right. So I'm going to create an array of ints, give it the values 2, 3, 4. And one thing with an array in Scala is you cannot change the size of it. So this array will always be an array of size 3. And then once this line, I'm going to click this step into button, which is going to advance one line in the program. This is going to run this line, and now we have a variable named array with the value 2 at index 0, 3 at index 1, and 4 at index 2. So the debugger is going to show me all the values in my thing, and I can make sure that it's what I expect, which it is at this point. I created an array with 2, 3, 4, expect those values to be in indices 0, 1, 2. And we got that. Now let's get into some syntax. To access the values in an array, we're going to use parentheses instead of brackets. A lot of languages use brackets. Scala says no. I mean, it uses brackets some places, like right here. But to access values in an array, Scala says no, we're going to use parentheses. These are actually method calls. Using the parentheses syntax, we're calling a method to access and overwrite information. So I'm going to say the value at index 1, whatever it was, it's going to be overwritten by 20, and we can see the change in our array in the debugger. We can use the same syntax to access an existing value. I want to get the value at index 1, parentheses, the variable name, parentheses, and access that value. So x is going to get that value 20 from index 1 of the array. So when you're doing this is really important when you're doing your splits. When you split a line and you expect there to be two values, country name, country code, or all the city values, when we get to the city data, you're splitting on that delimiter and you want to get the information from a specific index after splitting the string. That's how we're going to do it. Parentheses, and then the index of the value that you want to read. Iterating over the elements for variable name in data structure. And it's going to iterate over these values 2, 20, and 4. Again, I'm not doing anything interesting. I'm just printing them to the screen. But we can see, going into this loop one at a time, right now the variable element stores the value 2, the first element in that data structure. The next iteration element is going to be 20. And if we click over to the console, We can actually see that we've printed 2 to the screen. We're going to print 20 to the screen. Element is now 4. We're going to print 4 to the screen, and that's the end of the loop. Now, as you saw in 115, sometimes just iterating over the values isn't going to get us what we want. Sometimes we want the indices as well as the values. So if we want to iterate over the indices, we have to do something a little bit different in Scala, since we don't have that typical for loop that just iterates from like the JavaScript style, I equals 0, I less than n, I plus plus. We don't have that, so we have to do more of the Python style, where we're going to say for variable name in, and then iterate over the indices. And I have 3 examples here that do the exact same thing. We can iterate over the indices the way we saw in the looping lecture, the looping slides, where we take all of the values from 0, use the to method, and then array.length minus 1. The to method does include the end point, so we have to go to array minus 1, the length minus 1, if we want to iterate over all the indices. Alternatively, we can use until, which excludes the endpoint, and then just go until array.length. Or alternatively, arrays have this fancy method named indices, which gives you a data structure that you can iterate over and iterate over the indices of that array. This is the cleanest, this is the simplest, I would recommend this. In fact, the other 2 give me warnings where IntelliJ is like, you can use array.indices, that's there for you. It's a lot easier. Because this is asking for bugs. If you get this wrong, if you use until instead of to and do a little bit wrong, just asking for bugs. If you use array.indices, that's the easiest way to get through that. And then all 3 of these, I skipped iterating over them one at a time, but all 3 of these printed the same exact thing. At index 0, 2, index 1, 20, at index 2, 4. Then printed in the second loop, printed the same exact thing, third loop, same exact thing. All 3 of those 3 different ways of solving the exact same problem, just different approaches. I would prefer array.indices, but whatever your style, whatever you're used to, whatever you're comfortable with, that's the one you'll want to go with. And sometimes you do have to iterate over numbers, so it's nice to have until and to, having these methods in your repertoire, because sometimes you just have to do that. Like, I'm not running it this semester, but I had a lecture task where you had to find the prime factorization of an integer. For that, you had to use to or until, one of those, to iterate over the values you were looking for. You don't always have a data structure you're iterating over. Okay. Any questions on arrays and array syntax? Yeah. Yeah, those last three loops were doing the same thing. They'd all have the same exact effect. All right, so execution went back to the main method. And next, my list methods. We're going to take a look at the list data structure and its syntax. The list data structure is the one we'll use the most. It's the one I prefer when I'm writing lecture tasks and application objectives. It's more versatile than arrays. It just fits the needs of the course a lot better. And I don't know, just in general, I think it's a more versatile data structure. So let's take a look at list syntax. Creating a list, same exact thing as array. Give it a type parameter. This is a list of ints. It can only store ints. And I'm going to give it the values 2, 3, 4 because why not? That gives us a list with the values 2, 3, 4. Now we can't change an element in a list. So earlier, the first example in array was changing the value at index 1. There's no parallel to that in lists. We would have to delete the element and then add a new element in. That's one restriction of lists that makes it a little tougher to work with at times. But what we can do, which we couldn't do with array, which I personally is more useful, at least for the projects in this class, is append values to the end of it. And list, by the way, this is more like list in Python. That's not for a little bit. First, accessing elements. If we want to get the first element in a list, there are a few ways to do it. .head is preferred. This is the easiest way. Just do list.head, and then x is going to store the first element in the list, which in this case is 2. If we want to access an element by its position in the list, we can use .apply. We can also use the same parentheses syntax as we did with arrays. This will also give us the same thing. This will actually call the .apply method. It's just a little shorthand. The Scala developer said, you know what, let's give them that shorthand and just have it call apply, even though apply is the actual method. So this will work as well. Y is going to get the element, I clicked the wrong button there. Let me just reset my breakpoint and rerun this. So x is going to have that value, array of, why are we in arrays? Let me list. So x is going to be the head of the list, which is the value 2. And then y is going to be the element at position 1, which is going to be 3. So that's how we can access the elements of a list in by their position, by their ordering in the list. Now, the advantage we get with lists is we can add elements to the end of it or the beginning of it. Here's the syntax to add an element to the end of the list or append an element to the end of the list. We're going to say list plus colon plus the element that we want to add. So this is going to append 50 to the end of this list. And very, very importantly, we have to reassign the result of this expression to the list. So what this actually does is creates a new list that's a complete copy of the old list, but with the value 50 appended to the end of it. To get that change to be able to be seen by us, we have to assign it to some variable or value. In this case, we're going to reassign it back to the list, so that list can have the value 50 in it. Our list variable now refers to that new list that we just created with the value 50 appended to it. If you don't reassign, if you're doing this, it's a really easy office hour question to answer. Me, the TAs, we're just going to be like, well, you got to reassign to your list because you're creating a new list, creating this beautiful list with the values 2, 3, 4, 50, and you're just leaving it on the ground and walking away with it and not storing it in any of your variables. So list is still just going to have 2, 3, 4. You're not going to have that value 50. Same with prepending. For prepending, the order matters here, the value and then the list. You can remember this by the values going in the front of the list, prepended to the beginning. Here it's appended to the end. A little bit different syntax, colon plus and then the value, colon, colon, and then the list. Prepend to the beginning, and again, we have to reassign it to the list, or else we're never going to see that change. Now we prepend that to the beginning, and all the other values are pushed back by one position. Iterating, just like we saw before, for variable name in data structure, do whatever this says. So we're just going to print the values one at a time, and we can verify that they've been printed to the screen. Any questions on lists? Can lists have different value types? You can create lists with different types. Like we could have a list of doubles, list of strings. My examples today just are ints, just to keep it a little simpler while we're still getting warmed up for the semester. But you can have any type in there. You could have a list of strings, for example. Any type can be the type parameter. Can you append to a specific position in the list? It's a little trickier. You have to get a reference to the node that you want to append either before or after, and then modify the list that way. It gets a little tricky, or use list splicing methods, but it's not something we have to do quite yet. We have, later in the course, we have a data structures module. The learning objective 4 is all about data structures. We'll go in depth on how to do all kinds of stuff with lists. But for our purposes now, we don't have to append to the middle. But you definitely can do that. Yeah, you can't mix and match the types, though. Like you can't have, at least not yet, in Learning Objective 2, we'll see some ways where you can do this. You can't have a list with multiple types. So I can't say, I want this list to have ints and doubles. We can't do something like that. You have to choose a type. You have to choose a type for that list. Oh, I have to do this in every lecture. 150 to 40. Okay, 12 minutes. With the 20-minute buffers, I'd never remember. 240. So with maps, similar, except this is our second of many arrows in the semester. Scala developers love their arrows. The map, we're going to specify two types, the type of the keys and the type of the values, which can be different. Again, I'm just sticking with ints for today, but this could be ints to strings to ints, like in your lecture question, which we'll see when we get to the slides. And when we specify the key value pairs, the key and value are separated by an arrow facing to the right, dash greater than. That's going to specify that this is a key value pair to be stored in the map. So here we're creating a map of ints to ints that maps 2 to 4, 3 to 9, and 4 to 16. So integers to their squares would be the application here. That gives us a map with the values that we want. To add a key value pair to the map, a simple plus sign. Plus sign is going to get us there. So the map plus a new key value pair, and then always reassign it to your map. You have to reassign it to the variable storing your map. Which also implies, I didn't mention, but these data structures should be variables, not values, because we have to do so much reassigning to them if you ever want to modify the contents of it. You want to access a key, you can use that same parentheses syntax, get the value at a certain key. Then we get 525 in there. One danger of doing that, so X gets the value at key 3. The danger of doing this is if the key is not in the map, this will crash your program. Just end of program, everything crashes, exits, and nothing else is running. So it's a little dangerous. You have to know that that key is in there before you do this. If you don't know if it's in there, if you want to access something conditionally, get or else is your best friend. Get or else is going to access the element at a specific key, and if that key is not in the map, it returns this default value. So 100 is not in our map, so Y is going to get the default value of -1, the else of that get or else. To iterate over a map, there are multiple ways to do it. Maps have .keys, .values, like you saw last semester. But I prefer this strategy. You can choose your own. But I prefer this. There's a way to iterate over the keys and values at the same time. Just give it parentheses, 2 variables, and then iterate over your map with this. So 4 keys and values in my map, iterate over keys and values at the same time. Even if I don't need either the keys or the values, if I just need one of them, I mean, if Scala made it this simple to iterate over both, why not? Just iterate over both and then use the values or keys as needed. Or you could iterate over the keys and then access the values, or just iterate over the values. That's fine too, if you know you only need one or the other. For my money, I like this. It's that simple, so why not use that? then it prints out the keys and values. Oops, that's the wrong one. We should be able to go through these slides quite a bit. A lot of the slides are just going through that syntax, and since we went through them in IntelliJ, we should be all right. But the lecture task we have to talk about. So the lecture task today, city populations. We're going to use a lot of these things that we just learned. So write a method named city populations, which takes 3 strings. The first is the file name of the cities.csv file. The second is a 2-character country code, which can be a mix of upper and lowercase. If you downloaded the slides before this morning, that said that it will be the same case as in the file, but that's going to be a mix of upper and lowercase. I changed it in the document, but I forgot to update the slides still today. A mix of upper and lowercase of the country code, a region code, which will be exactly as it appears in the cities file, so you don't have to worry about upper lowercase with that one. And then what you're going to return are all of the cities in that country and region pair. So look through the file, and any city matching that country code and with any case and that region, pull the city name exactly as it appears in the file as the keys of map, and then map them to the population of that city, which is a column in the CSV file, the population of the city as the values of that map, and return a map mapping all of the city names to their populations as ints. So we're starting to mix quite a bit of things that we've learned so far, converting those strings into ints for the population, handling this upper lowercase stuff, reading a file, iterating over the data of the file, and the new one today, creating a map and populating this map with all of the information that you need. All right. So there are a lot of data structures in Scala. I show you this just to show you how many of them there are. Each box is a different data structure. We're only going to focus on a handful of these this semester. The 3 that we're talking about today are going to get us through most of the semester, and then in LO4, we'll actually use those 3 to build our own data structures, a little more complex ones. But there are a lot of them. Let me advance. But these are the 3 that we'll talk about. We just went through all the examples in the code, so I'm not going to dwell on all this too much. But I do want to focus on specifics about why there were certain things we can and can't do in the code. An array is a sequential block in memory. There's one block of memory that you get when you create an array, and that's it. Like, that's what your array is, which means it can't change. So once you get this block of memory, well, you create an array of a fixed size, you get that block of memory, and then the memory before and after that might be used by other variables and other programs even. So that array cannot grow because you can't ask for more sequential memory like that. To grow an array, you would have to create a brand new array somewhere else in memory, then copy your values over. So an array can't change size, but it can change the values in that array at will. Our syntax that we did in IntelliJ. A list, on the other hand, it's still a sequential data structure, but the data is stored all over memory. So whenever you have a value in a list, what you actually have is a node which knows 2 things: the value that's being stored at that location in the list and the location of the next node in the list. So these nodes are all over memory, and each node knows where the next node is, which finds the next value in the list. Now this is really nice because we can change the size of the list really easily. We just create a new node and have a reference from another node to that node. Very easy to modify this list, which makes it nice and flexible. There are a few downsides of this. We don't actually have like addresses in a list. We can't access the value at index 5, for example, without going through the entire list. That's why it's the .apply method and not just looking up a value by index. Where with an array, we just do a little bit of math, and we can go to the exact memory address of a value at any index in the array, because it's all right in a row in memory. A map key value store. Big thing to remember with this, you can't have duplicate keys. That was a big thing in 115. Hopefully that was still hammered into your head in 115. Same thing here. Can't have duplicate keys. If you try to add a duplicate key into a map, your old value at that key is going to be overwritten. So this is nice if that's the behavior you want. If you want to update a value at a key, just add a key value pair with that same key and it overwrites that. But if you don't want that behavior, it's something you need to be aware of, that there might be duplicate keys. You're not going to have both pieces of data in your map. And all right, any questions? I didn't have too much to say in the slides after going through all the syntax already. Chat looks clean, so I'll see everyone Friday.